Everyone, this is Miss Polly, and this particular video will discuss about our chapter 8 entitled as Gravitation. The outline of this chapter will include from Newtonian gravitation, gravitational potential energy, the escape speed, and last but not least is the Kepler's law. Now, gravity is one of the most basic force in the universe. It plays a fundamental role not only in the structure of our solar system, but also in the way objects behave on Earth. So the definition of gravitation can be written or expressed as this, which is the first one, is the force of attraction between two objects in the universe. Gravitation is also maybe the attraction of object by the Earth. And the force of this gravitation is proportional to the product of masses of the object and inversely proportional to the square of the distance between them, where it is independent of medium. Now, these particular definitions can be expressed by using the law of universal gravitation, which is published by Newton on 1687, which is force is equal to G times with the first mass of the first object times with the second mass of the second object divided by the radius square. So for example, in these cases, I have these two planets, the moon and the earth. So F is the force between the masses, which is in this case is the force between the moon and the earth. And G is the gravitational constant. M1 is the mass of the object. So for these particular cases, the first object is the moon. So M1 is the mass of the moon. And M2 is the mass of the second object. So M2 is the mass of the earth. And R is the distance between the center of the object. So the distance between the center of the moon to the center of the earth is equal to R. Now, G is the gravitational constant. So the value of G is equal to this one, which is 6.67 to the power of negative 11 per kilogram meter cube per second square. Please bear in mind that this particular constant will not provided to you during your final exam. So please memorize the value. Now, move on to the next subtopic, which is gravitational potential energy. So any object in a gravitational field has gravitational potential energy due to its position in that field. Previously on your chapter 4, you did learn about the expressions of potential energy, which is it is the product between mass, the gravitational acceleration, and the height. However, this particular equation valid only when the object is near the surface of the Earth. So for the moon, it has a gravitational potential energy due to the gravitational field of the Earth. Also, the Earth itself has a gravitational potential energy due to the gravitational field of the Sun. So the gravitational potential energy depends on the distance between the two objects of this or this. Now, that particular potential energy can be written or expressed using these equations, where U is the gravitational potential energy with the SI unit of joule, equal to the negative G. G is the gravitational constant, similar value with the one that we just learned, and M is the mass of an object or planet that interact with the Earth. ME is the mass of the Earth. It's supposed to be constant with the value of 5.98 to the power of 24 kilogram. And R is once again is the distance of an object or planet from the center of the Earth. Now, the next subtopic is about escape speed. If an object is projected upward from Earth's surface with a large enough speed, it can soar off into space and never return. This particular speed is called as Earth's escape speed, also known as escape velocity. Now, this equation can be expressed with these derivations. So it is starting with these derivations, which is kinetic energy plus with the potential energy, where in this case, where in these cases potential energy is the gravitational potential energy, and kinetic energy can be expressed by using this equation, which is half mv squared. Now v in this kinetic energy also known as escape velocity. So rearranging these expressions, you can get the value or the equations of escape velocity, which is equal to 2g. G is the gravitational constant, me is the mass of the earth, m is the mass of the planet or any object that will interact with the mass with the earth, divided by the radius of the earth. So this is escape velocity. Now the last subtopic today is about Kepler's law. Kepler's law is a summarization of a long journey of research about the movement of the planets. So the complete analysis of this research about the movement of the planet, stars, and other celestial bodies in universe is known as the Kepler's law. Now, Kepler's law emphasizes three main points or three main summarizations of the law. The first law states that all planets move in elliptical orbits with the sun at one of the focal points. The second law states that a line drawn from the sun to any planet sweep out equal area in equal time interval. And the last but not least of the third of the law is the square of the orbital period of any planet is proportional to the cube of the average distance from the planet to the sun. This particular law also can be expressed in a term of equations, and that equations can be derived by using the Newton's law, where Newton state that the second Newton state that force is equal to the product of mass and acceleration. In these particular equations, mass here is the mass of the planet, and a, which is the accelerations, is represent of the centripetal acceleration. And you did learn previously, which is acceleration or centripetal acceleration can be written as v squared over r. And this particular force also equivalent with the force with the gravitational force that we just learned in this chapter. So by substituting the v is equal to 2 pi r over t, which is t is the period, I can get a new expressions of this equation, which is equal to this one. And by rearranging all these equations, you will get an equations where that equations is the statement about the third law, which is talk about the orbital period, which is these expressions. Now, these particular equations or this particular expression, which is 4 pi square over g times with the sun, with the mass of the sun, is also known as the Ks. Ks is the Kepler's constant, and the value of this constant is equal to 2.97 to the power of negative 19 second square over meter cube. So this is Kepler's law and this is gravitations. Yes, this chapter is a very short chapter. To understand more on this chapter, please check on the video where I will explain about an example for each topic. That's all for this chapter. Thank you.